4AC is an incredibly wide topic consisting of sinusoidal waveforms, complex number calculations, and more. But for today, we'll be concentrating on the RC transient circuits. With a DC power source, the capacitor is like an open circuit. Transient means momentary or for a short period of time. So a transient circuit is a circuit that changes from one DC configuration to another DC configuration. Finally, with a AC power source, the current and voltages of the capacitor are constantly changing. So the capacitor will thus be constantly charging and discharging continuously. The decay is characterized by a time constant tau equals to the product of resistance and capacitance. RC determines the time scale for the transient. Changing resistance changes charging or discharging current. Changing the capacitance changes the amount of charge required. So after about 5 time constants, most of the change has occurred. Say for example, if tau equals to 5 RC, 99.3% of the transition is done. Electrons are drawn from the positive end of the capacitor to the resistor, and then to the positive terminal of the battery. This creates the positive charge on the positive plate and negative charge on the negative plate. The transfer of electrons continues until the potential difference across the plate is equivalent to the voltage of a battery, or until Vc is equals to E. The transfer of electrons is very rapid at first, but slows down later and will eventually reach zero, meaning that current will eventually reach zero. Therefore, when the voltage across the capacitor equals the battery voltage, the transfer of electrons will cease. The other formula that's needed to be known is Q equals to CV, where Q is charge, C is the capacitance, and V is the voltage of the power source. Phase has passed, steady state will be achieved, and the capacitor is like an open circuit. In the VC charging phase, the voltage rapidly increases at first, and slows down and eventually equals the voltage of the battery source. In the IC charging phase, there's a very rapid decrease in current and eventually reaches 0 A. This is because the transfer of electrons is very rapid at first. However, over time it will slow down and eventually stop. And since the transfer of electrons stops, so does the flow of current. Do note that when current reaches 0 and when Vc equals to the voltage of the battery source, they have both reached a steady state. This is the discharging phase. When the switch is at position 1, the capacitor will begin charging. However, once the switch changes to position 2, the capacitor will begin to discharge. Vc during the charging phase. At first, the decrease of Vc is very rapid at first and slows down over time and eventually reaches 0. However, in the IC discharging phase, the value is negative because during discharging, when the switch changes from position 1 to position 2, the current will start flowing backwards, and so the current starts off negative. However, it will eventually reach 0 over time. So now we'll be comparing RC and RL transient circuits. So apart from RC circuits using capacitors and RL circuits using inductors, they have other differences as well. So for the time constant used in RC formulas, the tau in RC circuits is a product of the resistance and the capacitance, and the time constant in RL formulas is the ratio of L against R. Next, RC circuits are used to charge capacitors, and RL circuits are used to store energy. In steady state, the capacitance represents the open circuit, and in RL circuits it represents a short circuit. So this is the RC circuit, RL circuit. So one of the major differences in both the circuits is that obviously the RC circuit uses a capacitor and the RL circuit uses an inductor. Other than that, there's not too much of a difference. So this is the RC discharging phase, and this is the RL decay cycle. Like before, in the charging phases and the storage cycle, there's not too much of a difference in the circuits other than the capacitor is used in the RC circuit and the inductor is being used in the RL circuit.
Hi Mr. Yang, hi friends, if you're actually watching this. We hope you actually learned something, because we definitely did learn something. And thanks for paying attention.
Yeah, we had a lot of fun. We hope you enjoyed this video. Thank you.
Bye.